Greetings everyone and welcome to today's video where we'll be seeing how to perform a two-way analysis of variance with interaction terms in R. First of all, we'll start by loading a few libraries in R. The tidyverse library is an amazing library because it's a super library which contains many packages inside of it which are very useful. The summarytools library is useful to get summary statistics with minimal lines of code. The law stat library will help us to perform an assumption test, which is the Brown-Forsyth test. The ggpubr package or GG publication ready package is good to get publication ready plots. The emmeans package will help us to compute estimated marginal means, and the report package is amazing to write automated statistical reports. So for the purposes of this tutorial, we'll be working with a tooth growth data set. This is the same data set which we have used for the one-way analysis of variance, where we only concerned ourselves with the dose of vitamin C. More details are provided in that video. I will now store the data set in an object df so that it is easy to call this object at a later date. The str function or the structure function will help us to get a structure of the data set here. If we want to get more information about this data set, we can write a query in front of tooth growth and we get a description. So this data set contains the response of the length of odontoblasts, which are the cells responsible for tooth growth, in 60 guinea pigs. Each animal received one of three dose levels of vitamin C, 0.5, 1, and 2 milligram per day, by one of two delivery methods, either orange juice, OJ, or vitamin C or ascorbic acid or VC. So we want to see whether the dose of vitamin C is responsible, whether higher dose of vitamin C are responsible for more tooth growth, and whether the delivery method like OJ or vitamin C is better than the other. So now in if we run the structure function, we see that dose has been encoded by R as a numeric variable. This is due to the fact that R has recognized that these values are 0.5, 1, and 2, which is numeric. But in fact, these are factors or categorical variables, and we want to keep them as factors. So we can do this by the as.factor function, and now we can rerun the structure function and we can see that the dose has now been correctly encoded as a factor variable with 3 levels. We can now attach our data frame to enable easy calling of variables. And now that we have attached the data frame, let's see how the data looks like. So the head and tail functions give us the first and last 6 rows respectively of our data set. So we can see that there seems to be no problem and the data set has been loaded properly. Now, before running any test, we would first like to do a data exploratory data analysis. You can get some summary statistics. So we can do this using the df summary function provided in the summarytools package. And I want to group those by dose and the delivery method of vitamin C. So they're going directly ascorbic acid tablets or orange juice. And we'll be storing the results in this object sum1 and sum2, so that later on we can actually call upon these objects and view them using the view function. So here we can see that the mean tooth length in the guinea pigs who were given 0.5 milligram per day of vitamin C with who were given directly vitamin C tablets was 8. Those who were given 1 milligram per day had a mean of 16.8, and those who were given 2 milligram per day had a mean of 26.1. So we can prima facie see that as the dose increased, the tooth length of also increased. This is for vitamin C, as you can see here. In this data frame summary, we can also see whether we have any missing values. So we can see valid and missing values. So here we don't have any missing values. So that is good. And we can run the same function for the mean tooth lengths for guinea pigs who were given vitamin C through orange juice. So we can see that those who were given zero point 0.5 milligram per day of vitamin C through orange juice had a higher mean than those who were given vitamin C tablets. And the response here as a dose increased also looks to be linear. We can actually check this graphically using the ggplot package, which is included in the tidyverse package. So the ggplot function will help us to start plotting our ggplot. We can include the data set or data frame object inside this ggplot function. We want to get box plots because we can visualize medians with their interquartile ranges. The ACE function stands for aesthetics. It can we can provide arguments for the variables we want to provide on the x-axis, y-axis, and whether we want to fill with any color, fill with any group. And the facet underscore grid function helps us to group in separate plots. So if we run this function, you can see how this works. And we can see that the guinea pigs who were given orange juice and those who were given vitamin C and increasing doses. So in both of these methods of delivery, we can see that the tooth length, the median tooth length has increased almost quite linearly. Now we can do perhaps arguably a better visualization method by grouping these box plots using a similar line of code, but we will remove the facet underscore grid so that we get it in a single plot. And we can see that those who were given orange juice, those guinea pigs who were given orange juice, 0.5 or 1 milligram per day, had a higher median tooth length. But there seems to be no apparent difference in the median tooth length in those who were given 2 milligram per day. So those who were given 2 milligram per day, the method of delivery did not is not apparently different. But those who were given 0.5 and 1 milligram per day, orange juice seemed to be better in increasing their tooth length. So these are all speculations, and we need to statistically prove these findings from our exploratory data analysis. So for this purpose, we'll be running a two-way analysis of variance. We are saying this two-way because we are going to include two independent variables, that is the dose of vitamin C and the delivery method. So before running an analysis of variance, we would like to check certain assumptions. So dependent variable is continuous, that is fulfilled. Independent variables are factors at two or more levels, that is also fulfilled, as we saw in the structure of the data frame. The observations in each group are independent of each other. So that is to say that there are no two observations from the same guinea pig. So that is also true. The observation are random samples of the population. We are hoping that the researchers have fulfilled this assumption. Now these are two assumptions we can test statistically. So each sample was drawn from a normally distributed population, the assumption of normality. We can run the Shapiro-Wilk test, which is statistical test to check this assumption, or we can visualize data using histograms or QQ plots. We'll run the Shapiro-Wilk test for this tutorial, and for each group, so each sample for two-way analysis of variance means those guinea pigs were given 0.5 milligram per day through vitamin C, 0.5 milligram per day through orange juice, similarly for 1 milligram per day, 2 milligram per day. So we'll run the Shapiro-Wilk test for each of these groups. And mind you, a significant p-value in the Shapiro-Wilk test indicates that the data are not normally distributed, and a non-significant p-value, that is a p more than 0.05, indicates that the data are normally distributed. You can see that all of these p-values are more than 0.05. That's a good sign because the data are normally distributed and we are okay with running a parametric analysis of variance. If this was not fulfilled, we might have had to run a non-parametric test. Now, the assumption of homogeneity of variances, that is the variances of population samples from which the samples come from, are equal. We can run a Brown-Forsyth test, which is a modified version of Levene's test. It is more robust than Levene's test. However, this test is run through the Levene.test function itself. You might find it confusing, but this is how it works. So this is a modified robust Brown-Forsyth Levene type test. And similar to the Shapiro-Wilk test, a significant p-value indicates that the data are not, the variance of data are not homogeneous. That is, there is heterogeneity of variances. But in this case, p-values are not significant and there is homogeneity of variances in both the groups. So that is a good thing. Now, finally, because all of these assumptions have been met, we are good to go and we can run a two-way analysis of variance with an interaction term. Now, what is an interaction term? An interaction term will take into account the effect of both two or more independent variables simultaneously. So this is the interaction term I'm talking about. In R, the variable on the left hand side of the tilde is a dependent variable. The variables on the right hand side of the tilde are the independent variables. So this is something you would need to note down. Now, I could not have included this interaction term and seen the effect of these two variables. However, we want to see whether there is an effect of both of these variables simultaneously. So if you remember what we saw for 0.5 and 1 milligram per day, we saw that orange juice might be better in increasing odontoblast length. So this could not have been done without using an interaction term. However, an interaction term which can be done by just placing an asterisk in between these two independent variables will help us to do just that. We'll store the results in an object we'll name fit. We'll run this and we will use the report function from the library report to automate our statistical report of the ANOVA. And this is, in this case, for complex analyses, this function is a lifesaver because it saves you a lot of time. Here we can see that the main effect of dose is statistically significant and large. That means, as we saw that as the dose increased, the mean tooth length also increased. The main effect of the type of delivery supplement is also statistically significant and large. So these large effect sizes are based on these eta squared, partial eta squared effect sizes, and these are labeled using fields recommendations from 2030. You can also see here that the interaction between dose and supplement is statistically significant. The effect size is medium. The partial eta squared is 0.13. That's a medium effect size. And confidence interval, the lower bound is almost reaching 0, which is a null effect size. The p-value is significant. So that means that this interaction between dose and supplement is statistically significant, and we need to take into consideration the effect of both of these variables simultaneously. How do we know which result is statistically significant? We can do that using post-hoc tests. We can check estimated marginal means. Estimated marginal means are not raw means. So these means actually take into consideration both two or more variables which have been included in the model, independent variables, and they adjust for these variables. So how do we run this function? So this emmeans function is from the emmeans package. We have stored our results in an object fit. We can run this pairwise because we would like to see pairwise differences in our post-hoc test, and we will include our interaction term on the right hand side of the table. And we'll store the results again in an object em because it will be easier for us to call upon this object later. Now we'll see what results we are getting. So we can see that guinea pigs who were given orange juice 0.51 and 2 milligrams per day of vitamin C, we can see their means and their confidence intervals. And we can see that as the dose increased, the tooth length also has increased. Now contrasts are good to check the difference. These are very useful to check the difference. So we are actually interested in, because we saw here in the data visualization, we saw here that for 1 and 2 milligrams per day, we actually saw that the delivery system actually probably does matter. So you can see that for 0.5 milligram per day between OJ and vitamin C, the estimate is 5.25. There's a difference between the type of delivery, and the result is also statistically significant. Mind you that these p-values have been adjusted for multiple comparisons automatically using the Tukey method for multiple comparisons. So we can see that yes, at 0.5 milligram per day, the delivery system does matter. What happens at 1 milligram per day? So this is the contrast we want to see. This is also statistically significant. The method of delivery also does matter here. But what about at 2 milligram per day? We saw here that the medians are similar, are in fact the same here. So does the method of delivery matter? When we are giving 2 milligrams per day, we can check that using with the help of this contrast. So OJ and DC at dose of 2 milligram per day. And yes, the p-value is 1. So it is not statistically significant. And this reaffirms what we saw in our exploratory data analysis. So this is a great result. Now, if we want confidence intervals for these estimated marginal mean differences, so mind you that the estimate stands for the differences in estimated marginal means between 0.5 and 1 and so on and so forth. So we can actually we need to run a separate line of code, confident em. The summary does not provide us with confidence intervals to get confidence intervals. However, we don't get p-values here, which we got when we ran the summary function. And to visualize this better, to visualize the estimated marginal means, mind you again that these are different than raw means because they adjust for the other independent variables. We run a simple plot function which is included in the base R package, and we include our two-way analysis of variance model, the estimated marginal means object, and we have included this argument horizontal is false because if this was true, then it would have given us a horizontal plot, which is not aesthetically pleasing to see. So even here we can see that as the dose increased in OJ, the tooth length has increased even for VC. So that's it for this video. Thanks for watching.